So today we are doing problem count number of trapezoids 2, which seems like it's from a recent competition. Given the number 3625, so you are given a 2D integer array points in a plane. Return number of unique trapezoids that can be formed by choosing any 4 distinct points from points. Trapezoid is convex quadrilateral with at least one pair of parallel sides. Okay. Interesting. There is 500 points. Okay, that's wild. Coordinates are only up to 1000 if that changes anything, but there is million of them, so probably not. So let's just try to work through it with least many hints. Let's say I would unlock a hint every 15 minutes, so if I don't know, of course, but right now I'm looking at it and I'm thinking that I don't know it. Oh wait! Oh, I thought that you have to find all of them from the given set of points, but this is... Oh my days. Oh. Okay. Oh. Okay. Okay, so let's say okay, that changes things because 500 is quite low. I think that allows for potentially n cubed, but likely just n squared login. So let's see what we can do. Well, we go through all points and get their slope, right? And store the slope as a, I don't know, like a vector. Which we can normalize by reducing it. For example, 4-3 cannot be reduced, like divided by GCD, so they are not divisible, or then they don't have common divisors, right? And then that's it, I guess. And then we just, how many pairs can we do of that? I guess this does not have a problem. Okay, I think that's it. So let's see, that will be n squared with hash map n squared maybe, and then, well, we have to store the slopes and the count. Unordered map pair int. Can you hash a pair? Maybe. I don't know. Let's call this counts. Leetcode always is fun because they store points as vectors every single time. Anyways, so question is how we want to store dx and dy, because we might encounter points from we might encounter points in this order and then this order, so probably we want absolute values. Delta x is equal to absolute value of points I0 minus points J0, and in delta y is absolute value of points I 1 minus points J1, and then we need to find the GCD, so int G is GCD of dx dy, and then it could potentially be 0 if they are in line, but we will return the GCDs 1 in that case, and then we can freely divide. So, and then what we want to do is count of dxg and dyg plus plus, or auto slope is dxg, dyg, and then ans. Can there be log of them? No. So ans plus equals. But we have to avoid points which are collinear. Okay, I will check that later. Only, but two lines are parallel by this definition. There is no assumption on points. All points are pairwise distinct. But about the slope, if you have 4 points in line, there is nothing like that. So how to determine that? Yeah, we will check that later. So ans plus equals count of slope, and then we increase that count, and that's it. So we return ans, and then ans is this, and then boom. And okay, you cannot hash a pair, which sucks. Okay, so looks like count is, I cannot have pairs, so let's do map for now, whatever. That's weird. Okay, we immediately have this, no, because we have 1, 2, 3, 4, 5 also. This is one trapezoid. Wait. So, oh, because I don't have GCD defined. Why? What? Why is GCD defined? That is weird. There is GCD defined. 6 to have 2, 5, 1, 6, 0 have 6 GCD. That's not right. I think. No. If dx0 or dy0, then g is 1. Okay. Not sure this will work, to be honest. Output 0, expected 1. Am I supposed to draw these points? Are you kidding me? This has same y-axis and this has same, but they are what the hell? Use test case dx dy g dx dy g. 11017. I mean, how can you make a trapezoid out of this? You go from 30, so you go from minus 78, so all the way here, and minus 25 to here, and then you go to 72 minus 8, and 72 minus 8 and 32 minus 8. That does not make sense, bro. Well, the dx should be, so if the, wait, so only if dx, then what we do is, or dy is 0. Geometric problems are always about 10,000 edge cases, so if dx is 0, then we want dy to be 1, else dx to be 1. Okay, now these don't work, but that one works. So now I somehow have 3 possibilities. Here I have 2 possibilities. How is it possible, bruh? I can only pick one of them. What the hell? That's weird. Oh, they cannot overlap, right? Shit. Okay. But that's weird. You know, how you get 3? If I submit this, how many test cases I pass? Ah, it's judging, okay. It's just slow. 60, okay. It sucks. So 1 0 0 1. That's this line. No, that's this line, then this line, and then 2 1. It's this line. Okay. So nothing yet. Then here we can go like this. I mean, that's, it shouldn't be absolute, I think. No. I mean, I can sort the points like this. Okay, now it outputs something reasonable. Let's see. Okay, 66 cases, expected 0, output 3. That's great. Let's see. What the hell? Yeah, they cannot be collinear. My idea is that if 2 line segments with same slope are collinear, then their lines intersect x equals 0 at point x equals 0 at the same height. So why do I have to do math? There is no way this is an interview, bro. So if let's say we have a line segment from, I don't know, even this one from example, like I don't know, this, right? I would have to divide this to get the slope, and then so y is mxb and slope is m, and then y is well, we want to know b, right? So well, the b is difference in, oh my days, bro, what the hell? So we know slope, and then we want to know, but like this has a slope of -1, right? If I output, that's what x divided by y, maybe. Or difference in y divided by difference in x. Okay, so that's the slope divided by x. So int slope, no, int m is equal to dy 0, then it's 0, otherwise I don't know, it should be like 10 to 9 or something like that. So like some infinity slope, whatever. Then the slope is 0, otherwise dx is 0, meaning that it is a vertical line. Then slope is inf, otherwise it's dy divided by dx. Maybe floating, probably should be. Double this, double that, whatever. But map is not gonna work with a double pair. That sucks. I can afford to do that much. I can only compare 2 points. I mean, they can, like, if it would go here, then it can overlap anywhere, basically. Which kinda sucks, because then I can't use map on a double. And I cannot check if they are collinear. They could have just said that it doesn't contain 3 collinear points. That maybe hint 1. Okay, I got that, but what about collinear points? In each slope bucket of size k. Okay, I still got that. Skip any that shares endpoint, since it could not form a quadrilateral. What the hell? I got that, but shares an endpoint since it would. What the hell? Skip. But like, what if you have another line here? That could totally happen. I think in fact it does happen in this case. Like have 3 points in a line. But that's in like same x-axis. So they are all I got like minus 94, minus 15, 12, and then a little point here. But you cannot make a trapezoid out of this because it doesn't have two parallel sides. But that's okay. But what if I would have 4 points in a straight line? How do I remove those cases? I understand this, but what the hell? I don't understand this. I honestly, I was just quiet probably for a couple minutes. Problem is, I I'm not sure uh, how to count out the lines that are parallel to each other. Or are they saying that it's a valid trapezoid if I have like 0 0 0 1 and then I have like 2 points all the way here? Like if I check this pair and this pair, that's a valid suddenly, but of course this and this is not valid. But what about like this and this? What the hell, man? So I got the right ideas, but I'm just, this test case is wrong. I'm not sure how to store this, to be honest, so hash table plus geometry maths. That share same midpoint? What? What do you mean same midpoint? What is same midpoint? Intercept to distinguish non, yeah. Okay. So if there's, you set this to infinity, okay, and what's b? B is x1, that's fair. Otherwise, what's b? What the hell? How you calculate b though? Well, I didn't know about that. So, and what's midpoint? What the hell are they doing here? I mean, this subtracts the, okay, the same. What's midpoint? Why would this work at all, dude? What the hell? Like, let's say we have like, I don't know, 0 0 1 1 and then 5 5 6 6, and now by their logic you do 5 or 0 0 1 1 is 10,000 plus 1, and the other midpoint is what? X coordinates, so 11,000 plus what is a midpoint of a, what? Why is midpoint of a line calculated as sum of its coordinates of endpoints? I don't understand it. I do not understand. Because if I have points x1 and x2 for 0, 0 and 1, 1. That gives me 0 plus 1 times 10,000 plus 0 plus 1. So that's 10,001. And then we have another point 5566, which are collinear. That line segments are collinear. So you got 5 plus 6, that's 11, times 10,000, that's 11,000, plus, like, that's way off. What the fuck is this midpoint math? What is this? I don't understand it. What is this? And how do they calculate the B? Because I don't. This is interesting problem. This is very interesting. I could have pulled that out of my ass. That how should I know? In a parallelogram, the midpoint is the same. And is it really though in this? Like, is it really though? Because midpoint of like this is here, or even here maybe. It's 2.5. So the midpoint is right here. And midpoint of this, what the frick? That's n is relatively small and log behaves like a constant, and bro, this is such a bad analysis. No, what the hell, who did this? Who did this? Oh my days, that is disgustingly shit. Well, I need to remove the collinear lines. How did they calculate the intercept term? What's k? That's slope. Yeah, I got that. But k slope and b is intercept. What the freak? What the hell? So dx is actually this. I'm not sure why they even like. What is this? But okay, whatever. It should be just dy by dx, and this is what? That's y1 minus x1 divided times dy dx. What? I mean, I guess you just evaluate the point there because you have the slope, so you should do like kx should equal y, so we do y minus kx or mx. So double D is like points I1 minus m times points I0, maybe. And then we should have like another map in here for those map. No. Int count. No, that's slopes. And then we have map and like double. One guy said had here the rounding trick. How is that done? No way someone got this for Google interview for sure. Somewhere here this was. Yeah, so round. I mean, I guess we can do that, but so let's say we will have like a long, okay, long, and then count. So these are buckets by slope. So this is by slope, and I also count by slope. Great. So instead of this, we do slopes and then ans minus equals by slope long intercept is a double. I'm not sure what even double precision does have. Long double. Let's do this, and let's do like 1 in 9. So that's like long of b times 1 in 9, I guess. By slope intercept plus. How is that possible? Oh, because slope can be infinity. So what's the intercept then? If it's a vertical line. Let's do this. So instead of 1 in 9, let's do 1 in 6. Who cares? -3, that is ridiculous, dude. Okay. Fair. I mean, that's fair, I guess. Okay, that's just amazing. So let's do dx dy and then mb should work. Great. So slope is something infinite, right? And then term b is 0 for some reason. That's fair. So we have like, so for this slope you have I could not care and just put a long double there, but anyways, it's not a good idea to, as they said, to use double in a map, but so first we pick these 2 points, I think. Well, they should have infinite slope, I think, or intercept should be infinite, so then we do point I 0, otherwise we do this. Okay, well now even more cases are bad. So first we got 0, 1 slope, or what? No. So we got slope going like this. Its b is, so dy is not 0, but dx is 0, so it should be infinity. So slope is this 1e plus 9. I think so. 0.5. If I go like that, yeah, I have to normalize this. Okay, now only this is wrong. So let's see. So I have slopes of infinite between these 2 points, slope of 0 between these 2 points, and 0.5 between these 2 points. Then from here to here we got a slope of 1. That's not really true. Wait, so this with this, no, this with this has 0, and this with this has 0. But these have 0 and 1, so they are not gonna be counted, and then we have what, same slope of this and this, so that's the very last 2 points, so 0, 1, 2, 1, and then second to last, so this, and then this, so these two, so signs are wrong. Interesting. Dx ups, dx, dy ups, dy. I think this should work. Maybe. No. Okay. That's weird. So 0, oh, minus 1 immediately. That's interesting. Yeah. Like they go by, that's not by slope, but that's okay. So by intercept term. How to do the buckets? So I want to have per slope bucket of So this is the slope, and then for each of those I also want to have okay, I understand a bit, but okay, let's do this. MB, one more option. But okay, if I remove this, okay, now it passes. Okay, slopes, this should pass now, maybe. Okay, almost got them, but I don't think I can debug this. That is ridiculous, man. Maybe with some precision issues, I don't know that. Maybe long. Long m times 1 in a times inf long times inf So there are 4 points on this minus 89, right? No, 5 points, 1, 2, 5, and then 2 points here. This is ridiculous. What the hell, Bison? I mean, I can try to bring answer for you, but mean, technically I don't need this. Because if I have 2 points here, then how many ways I can pick it? 2 points up and 5 points down. Then out of that's 5, choose 2 basically. I should just do this, I guess. Let's not update the answer for now, and then for auto p, that's like a m count in slopes, and then ans plus equals count times count minus 1 divided by 2, and then for auto p count by slope still same answer, doesn't matter, because I did not change anything, 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 anything. So this we have just how many have this slope. So most have 0, and then one, 2, 3, 4, 11 is fair. But why is this the case? I don't want to understand that. apparently these have such slope, and then where is 1515? Here is 1515. Really? Three, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 times 6, so 66, and 45. So that's, yes, that means 11. 60, wait, 10 times 11, and 11 times 6 and 11 times 5. That's difference of 11. So the math is not mathing, I think. Well, not really, not all of them can be paired with all of them, in fact. Either way, still I don't see why it's what test result output 11 expected 10, because clearly there is this extra thing, right? So this 1515 is there twice. Really want to tell me that minus 75 minus 9, so that's difference in y is what, 66 maybe? Yeah, 66 difference in x, and 100. So 66, 100, that's like 3350. And 3350. Okay, so 3350, and then so there really seems to be a pair of points that this and this and this and this can match up to. So then the answer should be 11. Every time stupid as hard problem, bro. Oh my days. What is that? What are they doing? Slope to intercept. So slopes have these intercept. These slopes. Okay. It's probably just AI translation or something. This should not be hard to translate into any language. Rust, Leetcode, but this is Leetmeet. Entry K clone or insert vec new push B clone. What is this? 4 in Leetcode count. That is weird. You don't type return statements? Damn. That's crazy. TypeScript. That is disgusting. Anyways. 98.82, 94%. What's int2? What the hell? Oh, okay, so that's int. What the? X total. Oh my days, what is this? Maybe this is the editorial. All these codes are just AI generated. Rhombus deduplication. Rhombus twice, so I mean you are doing the same shit as they are, almost. Okay. Line ID, so it's previous parallel pairs minus the same. Okay. Update counts. Rhombus fix. When both opposite sides are equal. Oh! 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 What the hell? What the hell? Damn. Oh, this is quite... Oh. I mean... That is very interesting. By slope NB Okay, so rhombus fix when both opposite sides are equal. I mean, that's fair, so it's counted twice, so y side lane is no, this doesn't have to be there. Like this. Don't even have to divide by g. I don't even need g at all. So this is for storing guns. Maybe we can skip the point sort. Yeah, and let's see. We need to subtract the rhombuses, so slope line map pair long double int so what's that side count parallel, so rhombus slope pair of long double int rhombus line maybe, and then we want to do rhombus is this, and then rhombus plus equals rhombus slope of long double side length from Pythagoras theorem. This is like m rhombus line m b side length. Okay, and then minus equals rhombus I don't know how long is this even taking, but at least I understand it now. I understand it now, guys. This is a dead meme, but okay, I don't understand it as much. SMH. SMH. What? That's such AI result. I mean, to get views, maybe I should start doing AI descriptions. Maybe then someone will read my editorials, but whatever. I mean, I'm almost correct. This had 425 and this has 512. So if I somehow fix this, maybe I will get it, maybe. Pythagoras theorem of Pythagoras, as Chunk says. Anyways, well, that don't quite work. I mean, it does the same thing, I guess. I don't know. What am I doing with it? That cannot work possibly. Okay, so that was just rounding issues. Now it might pass. No, it still doesn't. That's awesome. how about we just round it, so round m to 9 places and round m to 9 places, and this shouldn't really be a double, but okay. Average CPP code. Let's do this. Round should it be? Anyways. Oh, okay, so that's still just rounding errors. No way! I actually did it. That's crazy. Okay. After 1000 years. Finally. It's been 1 hour 16 in just this recording, because after pausing the first one I accidentally said stop or pushed stop recording. So how to call this? A brute force. Okay, and what do we want to say in the brute force? So we can iterate over all lines, and two lines form two line segments form a quadrilateral. I have no clue if I'm typing in right. Oh, trapezoid. Okay. Trapezoid. Two line segments form a trapezoid. If the lines represented by the line segments have the same slope, they are parallel, but they are not collinear, i.e. represent the same line. Therefore, we count number of lines of distinct lines, and then we can pick and then for each line with count we can choose count divided by 2 trapezoids made of those lines. We also have to subtract but we have to subtract the number of lines number of pairs of collinear lines for each distinct line. Lastly, if the trapezoid is actually a rhombus, all four sides have the same length. All four sides have the same length. Is actually a rhombus. We double count them, so we have to subtract half of the rhombuses from the total number of trapezoids to avoid double counting to get the final answer. Lines can be identified by their slope, which we can calculate as dy divided by dx. Distinct slopes. If the lines have the same slope, lines with same slope let the slope of vertical lines dy0 be some large number inf. To subtract collinear lines, we have to subtract collinear lines. We have to identify lines by. We have to also identify lines by not only their slope but by a pair slope intercept. From the line equation y mx plus b we can calculate the intercept from the line equation, where m is the slope of the line and b is the intercept by using one of the two line segment endpoints. v is y minus dy dx. Finally, to identify rhombuses, we identify rhombuses by pairs m, slope and side length, where side length is dx squared plus dy squared from the pita side length is actually the squared side length which is Pythagoras theorem. We also have to subtract subtract impossible rhombuses as in the as with the lines by also identifying the rhombuses by triplets, slope, intercept, side length. Note that to avoid rounding errors, since using floating point numbers in map is not advised, since equality does not have to always hold. Like with integers, we use a fixed precision by rounding to decimal places. X equals round x times 10 to 9 divided by 10 to 9. For side, this is the reason. This is also the reason why we use integer, why we use squared side length instead of the real side length. N squared log n. Wait, but I mean worst n squared log number of. Can there be like n squared different slopes between each point? Maybe. I mean, it's still whatever. M squared log n squared is just n squared log n. Are n squared possible lines, and we do O log n squared work for each of them, since we of log n note that this holds because of the logarithm rule. Log n to a is equal to a c dot log n of an if a is a constant. Great. Since the query since we store the lines, the line represent line and rhombus, if we store in ordered maps, of n squared, since there are of n squared lines represented lines, there are of n squared possible lines from the endpoints. Note 1, note 2, we can lower the time complexity to O of n squared by not using an ordered map and by making up a hashing by creating a hash for the line representations. Okay, oh my days, that is ridiculous. That's crazy. Okay, goodbye.